All right, in this video, we're going to talk about some circle proofs. And I know we're saying the word proof, but it's really a good opportunity for us to put together some knowledge that we've learned in the past couple days and also circle back on some knowledge that we've learned in our past. And we're going to do that a little later in the video. But before we get there, let's talk about some theorems that we need to know about arcs and angles in order to come up or start our proofs. So the first one is that congruent central angles have congruent arcs, and congruent arcs have congruent central angles. So what I'm going to do to show this, I'm going to have a 1 and a 2 here. All right, so it's angle 1 and angle 2. I'm also going to call this CD in terms of my arc. And really the first line is saying that if angle 1 is congruent to angle 2, then arc AB is congruent to arc CD. And the second line is saying that if arc AB is congruent to arc CD, then angle 1 is congruent to angle 2. All right, our second proof says that congruent central angles have congruent chords, and congruent chords have congruent central angles. And this one, once again, I'm going to give my angle 1 and 2. So I'm going to have if, the first line is saying if angle 1 is congruent to angle 2, then chord AB is congruent to chord CD. And the second line says that if chord AB is congruent to chord CD, then angle 1 is congruent to angle 2. All right. Our next theorem is that congruent arcs have congruent chords, and congruent chords have congruent arcs. So this one, or my first line, is that if arc CD is congruent to arc AB, then chord CD is congruent to chord AB. And that second line says that if chord CD is congruent to chord AB, then arc AB or arc CD is congruent to arc AB. All right. Next, we have congruent inscribed angles. Congruent inscribed angles have congruent arcs, and congruent arcs have congruent inscribed angles. Well, we don't have a picture here, so let's draw one. Whoa, don't do that. That's better. All right, so if I have an inscribed angle, or actually two, which is needed. All right, so that's inscribed angle A, and that's inscribed angle B. And the arc that they intercept, this is going to be XY, and this is going to be ZG. And what I'm saying is that if angle A is congruent to angle B, then arc XY is congruent to arc ZG. And the second line says that if arc XY is congruent to arc ZG, then angle A is congruent to angle B. All right, now inscribed angles which intercepts the same arc are congruent. All right, I just want to highlight a couple key things there. All right, so what does that look like? Well, I have angle A intercepts arc DB, and I also have angle C, inscribed angle C, that intercepts the same arc. And the other way, angle D, okay, and B intercept the same arc. Well, those are congruent. So just straightforward on this one, angle A is congruent to angle C, and angle D is congruent to angle B. Okay, all radii of the same circle are congruent, and I just marked that. That's what makes a circle equidistant from the center. All right, and the next one we've talked about in class also, that an angle inscribed in a semicircle is a right angle. Well, this inscribed angle here that's inscribed in the semicircle, that's angle B, and its intercepted arc is AC. We know AC is 180 degrees. We know that B is half, so that is going to be 90 degrees. All right, so let's start taking a look at a proof. Okay, so let's talk about example number 1. I have given there that arc AB is congruent to arc CD, and I want to prove that angle ABC is congruent to angle DCB. Now, we should think, first of all, our picture, we see two triangles, and we're trying to prove that two angles of those triangles are congruent. And we have to think that if we, in our past, if we can prove the two triangles are congruent, then we can prove that their parts, angles and sides, are congruent through CPCTC. So that's really the approach that we're going to take for this circular proof. But we're going to use our knowledge that we just learned through our theorems to help us along the way. So the first thing we're going to do is we're going to mark that AB, that's arc AB, is congruent to arc CD. So those two are congruent. Now, something that's important is that we know that since those arcs are congruent, well, their chords are congruent. We just learned that. So we know that chord AB is congruent to chord CD. So we can mark that right away. Some other things we can mark is that we have, and we're looking at, and really, and I should back up, we're looking at this triangle here and the other one. So we're looking at triangle ABC and triangle DCB. All right, that's important. Now, so continuing with that, we know that, or we can see that angle A, let's get back to my colors here, angle A is inscribed, and this angle, inscribed angle, cuts arc BC, and then angle D cuts the same arc. So we know that angle A is congruent to angle D. Okay, now something else that we have. We have this angle. We were looking at the triangle. All right, kind of a little covered up right now, but I'm going to call this angle 1 and then this angle 2. Well, angle 1 and angle 2 are also inscribed angles, and they also are facing two congruent chords. So, and two congruent arcs. So we know that those two angles must be congruent. So really we have angle, angle, side. Now let's break that out a little bit because that could be confusing for some people. So what I did, or what I had, so A, B, and C. And then on the other side, I have D, C, and B. Those are the vertices. So I had 1 being congruent to 2, and that's up here. And then I had AB congruent to DC, and then I had angle A congruent to angle D. So I have angle, angle, side, angle, angle, side. I think that really helps. So you see that I'm already set up for my statements and reasons. So I'm just going to plug in and finish my proof. So I have number 1. I have AB, arc AB is congruent to arc CD. Well, we know that is given. And then from there, number 2, I went right at that chord AB was congruent to chord DC. And to that reason was arcs have, the reason is because the arcs have congruent chords. 3, I went at angle 1 is congruent to angle 2. And that reason was congruent arcs have congruent inscribed angles. Okay, number 4, I went at that angle A is congruent to angle D. Why? Because inscribed angles that intercept the same arc are congruent. Are congruent. And then after that, I could say that triangle ACB is congruent to triangle BCB. And 5, the reason is angle, angle, side. And 6, have angle ABC is congruent to angle DCB. And the reason is CPCTC. Okay, let's take a look at our next proof. All right, example number 2 is actually a little more straightforward. A little longer, but I think you'll be able to see this one, I think, easier than example 1. So it says, given that arc AC is congruent to arc AD. So I'm going to mark that now. AC is congruent to AD. It says BE is perpendicular to AC. So I'm going to mark that. BE is perpendicular to AC. And it says BF is perpendicular to AD. I'm marking that. B is the midpoint of CD. Sorry, midpoint. So immediately I'm going that CB is congruent to DB because of midpoint. Then it says prove that EB, I'm going to give green what I need to prove. EB is congruent to FB. So really I'm looking at this triangle here because again, I'm going to attack with CPCTC. So I'm going to prove congruent triangles, and I need to prove that EBC is congruent to FBD. So if I can prove those two triangles are congruent, then I can prove that EB, those two sides are congruent. Now, one piece that's missing is that we have these two arcs are congruent, and I have inscribed angles. I have inscribed angle C. If I extend, cuts AD, and then I have that inscribed angle D cuts CA. So those two angles are congruent. So once again, I'm going at angle, angle, side to prove. So I have angle, angle, side, and I have angle, angle, side to prove that the two triangles are congruent. So let's start right up here. So I have one, I have arc AC is congruent to arc AD, and that's given. I have two, what I just said, angle C is congruent to angle D. And the reason for that is that congruent arcs have congruent inscribed angles. Three, I'm going that BE is perpendicular to AC, and BF is perpendicular to AD, and that's given. I know we like to skip steps, but it's very important that we list that angle CEB and angle DFB are right angles. And 4, I'm going to write definition of perpendicular lines. Move this down. All right, 5. I have angle CEB is congruent to angle DFB. And I can say right angles are congruent. 6. B is the midpoint of CD. Line CD. And 6 is given. 7. I have CB. Line CB is congruent to line DB. And I'm going to write definition of midpoint. I don't like that. That's a little ugly. Whoa. And then 8, I can write the triangle EBC is congruent to triangle FBD. And the reason is angle, angle, side. And then 9, EB is congruent to FB. And the reason is CPCTC. All right, now, any parts of this video that you need to slow down, go back. You know, that's the beauty of the video that you can do that. As you can see, there is no check your understanding. So what I want you to do is really just, you know, get an idea. I know this one was really long, but really go over this material, especially those theorems, and we'll talk more about it in class tomorrow. Go Cats, go Knights.